And welcome back. Higher plus 5 a day, 17th of March. Let's just go straight to the first question. Right, what do we have? So a sequence of numbers is formed by an iterative process. So we saw one of these questions yesterday, didn't we? So it feels like we might get a few of these questions. They're quite good. Once you get used to them, they're not too bad at all. But all it's saying is I'm working out my next term by taking my previous term and doing this thing to it, which in this case is squaring and then taking away 5. It will always give me a starting value, which might be A1 or A0, and it will always tell me to get to somewhere, which in this case is A3. So A1 is equal to 3, given in the question. A2 is then going to take A1, which is 3, square it and minus 5. So 3 squared is 9, minus 5 is going to give me 4. And then to work out the third term, I'm going to take the second term, which is 4. I'm going to square it, which is going to give me 16, take away 5, and that's going to give me 11. So the answer to my question is 11. Next question. A sculptor wants to transport a piece of rock. It is a sphere, radius 0.4 meter. Right, okay. So as soon as I see nearest, I'm thinking bounds. And it is also the case, there we go, that the mass is also to the nearest 1 kilogram, or 1 sig fig, I should say. So let's just get the bounds dealt with first. And you know, again, it's not all about the exam, but frankly, it's a mark in the exam, so let's get it right. So the sphere is between the sphere is 0.4 to the nearest centimetre. Okay, I've just noticed something. Slow down a second. That's in meters, that's in centimetres cubed. I need to work in centimetres, don't I? And then convert later if I need to. So I've got 40 centimetres. To the nearest centimetre above is 41. The centimetre below is 39. So therefore my bounds are going to be 39.5 to 40.5. Now what am I trying to do? Let's not do too much work here. So the density is this. The truck can carry up to a certain weight. What is the maximum weight? So really I want to work out the maximum weight. And the maximum weight is going to be the volume times the density. So we've got the radius. Let's just quickly work out it's going to be minimum weight, isn't it? So the truck can carry 1,000 kilos to 1 sig fig. So 1 sig fig above is 2,000 kilos. 1 sig fig below is actually 900. So actually this is between 950 and 1,500, which feels wrong because it's not balanced either side, but those are the two numbers that I need. Anyway, that was all a bit messy for me. So just to sort of summarize quickly, I've got a maximum radius and I've got a minimum weight that can be carried. And I need to know the weight of my, what am I doing? The weight of my sphere is not more than the 950 kilos. How am I going to work out the weight of the sphere? Well, the weight of the sphere is going to be almost the mass of the sphere, I should say, is going to be the volume times the density. And that just comes from density equals mass over volume. And the volume of a sphere is 4/3 pi times the radius. And if I want the biggest radius or the biggest sphere, it's going to be the biggest radius. So it's going to be 40.5 cubed. And then times by the density, which is 3.4 grams per centimetre cubed. So I'm working in the correct units. So I'll put that in my calculator, which I'm going to do quickly. So 4/3 times pi times 40.5 to the power of 3 times 3.4 gives me 946,090. So 946,090, which on the face of it is considerably more than 950, the minimum weight the truck can carry, or the minimum maximum weight, if you see what I mean. Problem is, of course, that's in grams, because that's how the calculation works. So if that's grams, kilograms divided by 1,000 is going to give me 946 kilograms. Now, if this was a GCSE question, I need a really clear comparison. So I'm then going to say 946 kilograms is less than 950. So I've done my comparison. So therefore, what's the question say? Can the sculptor safely transport the rock? Yes, sculptor can carry rock. I've answered the question. Be careful of just writing yes, because yes can be taken two different ways. Question done. Next question. Right, a remote control car travels in a straight line. It starts from rest. I thought it was going to be a histogram question, but it's not good. It starts from rest and travels with constant acceleration, i.e. gradient is constant, for 15 seconds. So 15 seconds is here. All right, 15. 15 seconds is here, and it reaches 10, which is this point here. So if it's traveling at a constant acceleration, it's going to look like this. It then travels at a constant velocity, i.e. acceleration or gradient is 0, for 5 seconds. Well, 5 seconds takes me to 20 seconds. And then it slows down with a constant deceleration of 0.5 meters per second. Well, if it's constant, 0.5 meters per second will mean it will do 5 meters per second drop over 10 seconds. In other words, each 10 seconds it goes down by 5. So it starts at 10, 5, I haven't really done this very well, have I? So 5 is here, and then another 10 takes me down to 0. In other words, I recognise it hits 0 at 40 seconds. What does it want? So draw the velocity time graph. Well, I've done that. I kind of guessed what was going to happen. And work out the total distance travelled. So in other words, I'm going to add A plus B plus C. So your question now is, what shapes are A, B and C? Well, A is a triangle, so I can just say it's going to be a half times the height, which is 10, times the base, which is 15. Well, half of 10 is 5, and 5 times 15 is 75, so that's okay. And then I can add on B, which is a rectangle, so that's just going to be 5 times 10 as well, which is another 50. And then I end with C, which is also a triangle. That goes from 20 to 40, so my base is going to be 20. My height is also 10, and so that's going to be, well, half of 20 is 10. 10 times 10 is 100, so that's going to be 100. Add all these up, 100 plus 50 plus 75 is going to give me 225 meters travelled. So just to explain really quickly, it's a nice little question, just checking your understanding of velocity time graphs. Area under graph is the distance travelled, which is what I want. So really it's just draw a nice graph and work out the area underneath. And just to state the obvious, obviously if you get the first bit wrong, it's all wrong, which means the error will flow through. So do be careful with a question like that in an exam. Next and final question today. What do we have? So right angle triangle. If you see a right angle triangle, you only really know two things about right angle triangles. One's trigonometry and one's Pythagoras. And it says find the exact length. So I need to stay in surds. The exact length of the side labelled W, which is going to be this side here. Now, because I've got an angle and I've got a right angle, it's going to be trigonometry. This is my opposite. This is my hypotenuse. So therefore, I'm thinking that sine of 60 is equal to the opposite, which is W that I need, divided by 4 plus 2 root 3. Now, I know sine of 60 is root 3 over 2. This could be a non-calculator paper as well. So I know sine 60 is root 3 over 2. I'm going to multiply that by 4 plus 2 root 3, and that's going to give me W. And then basically I'm just going to tidy this up. So 4 times root 3 is 4 root 3 divided by 2, and root 3 times root 3 is 3, and 2 over 2, well, I'll write it down. So 2 over 2 is equal to W, which means my final answer for W is 4 divided by 2 is 2 root 3. 2 divided by 2 is 1 plus 3. So my final answer is 2 root 3 plus 3. And we got there. Good mix of questions today. We haven't had a velocity time graph in a long time, so it's good to do that. I really like this second question. This second question really got you thinking about bounds and how to answer a bounds question. And that change of units, look out for that. That was quite a clever sort of mix. The iteration question, again, I think there's a few of these probably coming, I would imagine, but nice question to make sure you understand. And a good surds question at the end. So in all, quite enjoyed today. Hopefully you did too. Let me know how you did, and I will talk to you all soon. Thanks all. Bye.